So I'm going to introduce Awalin SOPAN. She's in the Managed Defense group at FireEye as an engineer in the group and has deployed different machine learning models to support the Managed Defense effort. She's been an active member publishing in kind of the visualization community in security and ML. So we're excited to hear her talk on building explainable models for the SOC. Let's see if we can get this going. All right. Okay, so please welcome Awalin. Thanks.
Thank you, Jeff. Yes. Thanks all being so early. Yeah, really appreciate. And yeah, I think it's a good way of transition. Like Bernie just spoke about like how he's making APT similarity and also implementing models that are explainable to analysts and Intel. And in that sense, I think I can also mention like how we're doing making interpretable models for the SOC, which is our security operations center that we have in FireEye. And I will talk about the models we deployed for the SOC and how it's going to help them prioritize and triage alerts faster. So let's talk about like what are some of the biggest challenges in SOC we have these days. One is like we are getting lots and lots of alerts from various sources. So basically we have lots of data, and a lot of times, like most of the alerts that we get may or may not be true alerts. Like we have a lot of false positives. How do we get those alerts? They usually match some sort of signatures or maybe different types of detection mechanism. It may or may not be from some other machine learning models. So after those indicators are matched with different devices and like alerts, our SOC analyst gets to see those alerts. And then they use their analysis method and decides like whether it's really an alert or not, or whether it's a false positive. And after that, it goes to automation and validation. The problem is like it's that analysis and decision time that takes most of their time. So as you see, now we have more indicators, more threats, more devices, and very huge attack surfaces than before. More and more hackers and more malwares. What's happening is like we are not training people to actually deal with this huge volume of data. It can be frustrating at times. Also, it creates a bottleneck. What we want to do is create a model just for the SOC. So whatever the detection mechanism is, when the SOC analyst is going to decide or make the final decision, we want to make a model that will help them. And for that, we try to look into like the brain of a SOC analyst, like how they're thinking and how they decide on an alert, whether it's actually a threat or whether it's just a benign alert. For that, first we started interviewing that analyst. So for this project, we interviewed 6 analysts that work on our SOC, and they have different types of expertise. Some of them work investigating like alerts from network devices. Some others investigate alerts from endpoint devices, maybe an alert generated from a process event, or a specific file was written in a system. So when they look at an alert, we wanted to see like what type of indicators they look at, like what is their thought process, and what are the features they look at, and then what type of different type of pivoting they do. And based on that, we generated our feature space. So the difference between this process and like a data-driven process is like in this case, we are already getting, our training set is already the ones that are detected as possible alerts. And we are looking at only the features that a human analyst will look at. So basically, this is the diagram you see. Like an alert comes to the SOC, and the analyst makes a decision. And then we put it back to a training model, like, hey, this is the decision that our analysts have been taken. And after a while, we have enough data to train the model based on the analyst label. And the model will then generate, like, okay, this is what I think. And then as well as showing the alerts, we will also show like what the model think about that alert to an analyst. But the final decision is something that will be totally based on the analysts themselves. So after that process, like training the process, it comes to like, okay, we need to actually deploy the process. So this is more like an architecture diagram. So we have like a separate app for the training, then we have a predict app. So we wanted to keep them separate. So even if the model is, even if we deploy a new model, the prediction phase will not be hampered by the model deployment. And then this is the analysis tool, which is actually the analysis user interface, basically. So the analyst can see the raw alert and the model's prediction and all those like different context of that alert. And we are using a REST API, so the analyst interface will just talks to the predict API and gets the interpretation and the model's decision from the model. So yeah, before we thought about like, okay, what type of model we use and what type of visualization or user interface we will use, we had to think about like what's our goal. We wanted to have it transparent, and we wanted to highlight what features the model is looking at when it's training. And we've also like looked at different types of model, like we looked at decision tree-based model, also deep learning-based model. But in this case, since we wanted to make it interpretable, we went with decision tree-based model, because we wanted to, basically give a confidence to the analyst when they're looking at the score. And we tried several different type of decision tree-based model. We tried light LGB, and then we also tried like random forest-based model, and finally we went with random forest-based model. Basically, both the models performed equally, so there was no reason to choose one over another. So it was just easier to implement random forest because scikit-learn already had it. So we try to explain the prediction. So it's critical to generate trust when an analyst sees the score. They need to know, and basically our analysts are super experts, so we don't want to say like, hey, you think it's bad, but my model thinks it's good, so like which one you should trust? Definitely they will trust themselves. So we don't want like a blind trust for the model. We want them to understand like, okay, maybe we are trying to learn from their thought process. And what are the types of things we want to show along with the score? So we wanted to show like what are the important features and what logic the model actually took before generating that score. So we looked at previous works, like the LIME framework was good, but I thought like LIME is one of the things, it takes a lot of time just to generate one interpretation for each example. And then we also looked at for inspiration, like the H2O AI, you guys probably know about this. And then there are different types of graph we generally use for machine learning interpretation. But some of these are like more for understanding the model for the data scientist, not exactly to interpret the instance to a user or the end user who is not necessarily a data scientist. They just need to know like why you think the way you're thinking. So our process was pretty simple. From a random forest model, we made a decision tree for the final result of the interpretation. So what we did was, in our random forest model, we had like 250 trees, and it's majority voting for the final result. But then we also took like the top several features, and to generate like what are the top feature, we actually looked at, I should have had like a picture here, maybe I have it later. So we saw like what are the most important feature, and at what point that feature distribution becomes like a long tail and keep only the top ones. And then from that feature set, build a simple decision tree only for those features, and then run that alert with that decision tree to show the final interpretation. So the score is actually coming from the random forest, but the decision path that we are showing, that is from that representative decision tree. And this way, it's very easy for the analyst to understand, like, okay, this is the decision path that our model took. So that's all goes in the behind the scene, but this is, oh wait, we're not there, sorry. I already spoke about that, never mind. So yeah, this is the UI where our analyst will see like side by side. So previously, this was just an alert view. So this is an alert of a process. It's showing like the MD5, what's the parent process, what's the PID. Also, it's like fake data, so don't worry. And like, oh, what's the MD5 and what's the result from the virus total scan for that MD5? So you're looking at that raw data, and the analyst will just look at the raw data and will decide if it's bad or good. But now we have this prediction view where it's showing like, hey, my model thinks it's a threat, and it's like more than 96% confident that it is a threat. And why does it think it's a threat? So this is the decision path. I'm not showing it in a tree view because it's a UI, so we don't have like plenty of space, right? So they have to see like a lot of other things, so we are just showing the path. So this is all these conditions. So hey, the process count is 249, and it's above 28, and in those cases, it's actually threat leaning, and the parent process is not common.exe, and that's like all those different decision, and finally it's saying like, okay, for each of the branch of the tree, it says like, oh, if we just stop at this branch, it will be a threat. If we stop at this branch, it will be also a threat. So finally you see like at the end of the branch, it still thinks it's a threat. So finally it says like, oh, 96% and more confident that it's a threat. So this is more like for this specific alerts decision path. And at the side, we are showing like, okay, these are the most important feature for the model for all the alerts. So if you look at the model itself, you will see like the command length, the command entropy, process path length. Those are all like very important feature in our random forest model. So they can say like, oh, these are the important feature for the model, and this is how my alert fits into that model. Yeah, this is the feature vector I was talking about, like what are the top features. And so yeah, after that, after this few, it actually becomes like a very skinny, long tail. So I think like those are the features we discard when we make that final decision tree. And that's why the decision path is like pretty small. If we keep all of this, it just keeps growing and growing, and at some point, it doesn't matter that much to an analyst, like for those features. So the model is in production, and we saw some good results and also some not so good results. So it was important to go back to the analyst after 3 months of training data and then 6 months of like being it in production, like how you guys are actually using it. Does it even make sense to you? Or you are just completely ignoring, like I ignore like the Facebook ads in the right-hand side, like I don't even know that exist. So we wanted to know like how they actually look at that view. So I sent out 5 questions to the analysts, and 6 analysts replied to that questionnaire, especially the more experienced analysts who know more about the predictions and models, and they're more experienced in the SOC. 4 out of 6 analysts say they look at the score for a gut check, especially if they know it's a threat and they look at the score. That's enough. They won't go for the interpretation view. So one of the things we did is like, instead of showing all of the view at once, initially we only redesigned, so we only show the threat score. And if they want to see the explanation, they have to click a button and say like, okay, now explain it to me. So it's saving the UI space basically, because some analysts are so expert, they don't even need to know. They just be like, oh yeah, it's 96%, I'm 100% sure it's a threat, so I don't need to look at the explanation. But when it disagreed with the analyst decision, then they can actually look at that prediction interpretation and the whole decision path and say like, hey, your model is saying it's bad, but I know for sure that is false positive, or vice versa. So that view helps them this way, like, and then they can get back to us, and we can basically regenerate the model or fix the problems if we have. And 2 of the analysts, they are like, I think they're super expert. They wanted to know even more. And I think after looking at this model And the interpretation, they're getting more and more interested in the whole idea of machine learning. Like some of them email like, hey, can you like send me documentation or like about decision tree, random forest? So I'm like, is this because you don't trust, or are you like genuinely interested in machine learning? Whatever that is. So, but then I gave like a brown bag presentation, like how machine learning model works, because yeah, they're super expert in their field, so I cannot just say this is what a machine thinks, so they won't be like, I don't know, I don't trust your model. So after explanation, now we have generated like a more trustful environment, and they also feel like they can come back to us, give more feedback. And some of them got super interested. They wanted to know more context, like, hey, your model says like command entropy is like this. I want to know like the entire distribution of command entropy, like how it happens. So like I think I had one of the picture like that. Like in this case, you see like our model says like, hey, process path length is a very important feature. And in this case, you see when the length of process path is small, it's blue. So it's like most of those alerts are actually false positive. And if the length of process path is very long, in our training set, those are true positives. So some of them actually want to see those type of graph in their UI, which initially I thought overkill, but yes, if they want to, I think that will be nice to get more and more feedback from them. So we also have, we also created another UI component where they can type if they really hate our result or if they disagree or agree. And then I will get email and I will go back to the model and I can change or see like what we are doing wrong. And then we have some super excited people like Nikkar, I think Bernie also mentioned. He not only like sent feedback, he tweets about it. So this is my screenshot. Like this was, I don't know where are we like, so this was real data, so that's why you see lots of like censored. So the model said like it's 93% sure that it's a true positive, and you see like that's the final version, so we don't actually show the explanation by default. It's hidden, you have to click that button. And here he says like, as an analyst, when he sees that, he knows that it's bad. So as a developer of the model, I feel like, oh, I'm doing something good. I don't know why, but I'm doing something really good. And so yeah, at the end, we think like now that we are gaining more trust from the analyst, we can move further. Especially, it will be really helpful if we can just weed out all those false positive and don't bother our analyst with that. So we need to know like when the model says it's false positive, it should be like, we should be very confident that it is false positive. So we are looking at the distribution, so not just correctness or accuracy, we are also looking at what point of confidence it's really accurate. So if you see that when the model is like less than 65% confident, it makes a lot of mistakes. When it's like 80 to 95% confident, in most cases it's correct. But when the confidence score is 95 or up, it's almost 100% it is confident. So for those cases, we are feeling confident that we can just automate the decision and we don't have to bother the analyst. Like those are like very mundane, repetitive alerts. Maybe the model have seen enough data of that type of alert. And for that, we can only present to our analysts like very critical alerts that they can utilize their smartness and their intelligence, and the model can take care of the boring ones, and it will save time and save lives, I would say, sure. And our analysts will be happy. So yeah, I think with that, I will conclude my talk. And thank you, Matt. And I would also like to thank you, Michelle. She is from our Intel team. And Matt and I, we wrote a blog post which explains the more technical details of this process. Take a look. If you don't want to copy the blog post, just take a picture of the URL. Yeah, thank you.
Great. Let me ask one question before kind of handing the mic off. So thank you, Awalin, for the talk.
Oh yes, thanks, Jeff. I didn't write your name because you are an organizer, so I don't know if it's legal or not. So
I do not feel slighted.
Okay.
That's okay. Thank you, though. I'm really interested in the interaction between you as the machine learning modeler, researcher,
modeler is
and,
a good word.
and the analyst.
I'll use it as my job title for now. Yeah.
So have you learned something about the way that the analysts want to give you feedback that has evolved over time, your thinking? So you mentioned like having a text field that you let them write comments in. I just wonder if there's, your thought process has changed about how you gather feedback, in a more scalable way as you go.
Yes, thank you. For example, say this tweet. Most of the time, it's not a screenshot, but the analyst will say like, hey, your model says it's like 75%. Sorry, one time the model says it's 65% confident that it's a threat. One of the analysts says, your model only says 65%, but I'm 100% sure it's a threat. I'm like, it still says it's a threat. But yeah, it's like free form text, right? It doesn't say like, hey, your model says like the entropy is this, but I don't think it's correct. So they are not actually marking each of the fields. Or like, hey, I want to see more result. Like another comment was like, they looked at the virus total result for the MD5, and they basically wrote that the virus total result is really bad, so the model should also say that it's bad. So after getting that feedback, I also included the virus total result as a feature to my model. But again, those are like very one-to-one. There is, for now, we don't have like what is wrong, like more like easy to parse than a human reading those comments, right, and going back and forth. Another comment was, it came out from that survey. Actually, the survey was also free-form, but then I had to go back and like, they sit in next room, so it's really easy to go back and speak to them. One of them said like, hey, it says, like this is the result, everything, but it was detected by that signature or that heuristics. So I want to know what happens with other alert before, which are from the same signature. So they wanted to see like a confusion matrix, not the whole model, just for the signature. They did not use the word confusion matrix, but when they explain what they want to see, I'm like, oh yeah, it's called a confusion matrix, so we can give it to you. We have that result. So instead of like seeing what the model is doing for entire data set, they wanted to see more like categorized based on different signature and based on different category, basically. Like, or another one was like different clients. Definitely, I cannot have any screenshot of any client-related thing, but those are like many different feedback we got. But I really like the idea of having more like a structured way to get their feedback. And I think one way to for that would be even not just from them, like for us, to have a UI, like these are the features and how you want to give it a feedback. Yeah, thanks.
Yeah, what do you do when the data that's available in the alert isn't sufficient to make a decision, and the analyst has to go and pull additional data in, like pulling memory from an endpoint or querying whois or passive DNS or any sort of extrinsic data? Do you have any way of capturing that in your model, or are you just not able to make a decision there, or what?
In this case, like the confidence will be really low. Like whatever decision you will see like is dangling between true positive and false positive, and our analyst will know that do not trust this model at all. And that's another thing we did before implementing the models. We looked at like for what type of alerts we have enough data that we can actually build a model. Like we have 4 different models for SOC right now, but we have many different types of alerts. So for all those alerts, we still don't have the model because for some, it doesn't matter. Like if it's an APT, we don't care what the model says. We need a human to look at it. So we try to see like which ones are the case we have enough data that we can, not just enough data, we understand the data and we have enough information that we are presenting to an analyst so we can make a decision. Another thing was like, even if you have like a data-driven model, like a neural network or anything, it's used for detection, right? So when an analyst saw this alert, it's already detected as a bad thing. Now they have to decide based on what they can interpret. They are looking at a UI. So we wanted to see only use those features that are like used in the UI before and use those features for them. But you are right, like a lot of them, one of the feedback was like, yeah, they wanted to know more context. They wanted to pivot around various features. So they want to go back and go to like different intel and see like, oh, what's happening here? Especially those cases where the model is like not making any decision or the decision it's making, it makes no sense. And going back to Jeff's question, it makes sense to show like, okay, these are all those previous alert from that same signature, same type of alerts, and they can see like, oh, in previous cases, the model was also undecisive or wrong, so just let's not trust it at all. Okay, thank you. Good question.
Hi, I was wondering if you could expand a little bit on the decision path taken. I know you said you're using a random forest, but it looks like you're using just like one decision tree to show that path.
Yep.
How do you choose that tree, or is that the case that you're just using one tree?
Sure, I don't see you, so. Oh, thank you. Thank you. Yeah, so when you see that score, it's coming from the random forest. When you see this path, it's from that representative decision tree, because we have 200 and more than 200 random trees, and we don't want to show all of them because, like, what's the point? They are not. They will probably look at that screen for like 2 seconds. So what we did is, okay, these are the most important. Sorry, I'm going back and forth. Like, these are the most important features from that decision tree. Let's make a representative decision tree from that model, which is very simplified. And it will just give like a decision path, which will be, the final decision will be same as the decision tree, but the score it is giving is not the score. Like, we are not taking the score from the decision tree because it's just one representative decision tree. No, sorry. We are Hiram's question was, am I making a new decision tree for every instance? No, that's why we did not go with Lime. So it's like these are the maybe top 20 features, and that's the decision tree that we are using for the interpretation. So if you are looking at the score from the decision tree, it's not like super accurate.
When you're getting ready to deploy a new trained instance of a model, do you do anything like probability calibration or trust score to try to more transparently deploy a new instance so that the end users don't see a big shift in behavior?
Oh, thanks. That's a good point. We don't do it so far. What we are doing is trying to look at like what type of signature it was correct before, or if there was any surge of badly written signature, we try to like get rid of those signatures. And another thing we want to do is when we are training, we don't train with like data that is too old because behavior changes. So every month we are training it, and we take like our training data set shifts month to month. So we are training with 6 months of data, but it shifts every month. So most of the time we see like the performance score is growing, but we saw a sudden drop in 1 month. And then we went back and saw like what was happening. So there was a badly written signature that created like a surge of alerts. So next month we should have like removed that signature. That's not part of this talk, but I am working on it. So in future we will have like a more process to see like how we are filtering out bad data. Thanks.
Okay, let's take last questions offline with Awalin afterwards. So please give her a round of applause.
Thank you.